Assalamualaikum and very good day. My name is Muhammad Firdaus bin Ishak, a student in Master of Science in School of Electrical Engineering, University Technology Mara. Today I'm going to present to you my current research progress which entitled Implementation of Deep Learning Network to Detect Distracted Driving Behaviors in Night Driving. So we're going to look at presentation outline. Number one, background study. Number two, problem statement. Number three, research and objectives question. Number four, significant study. Number five, literature review. Number six, methodology. Number seven, data analysis. Number eight, result. And number nine is current progress. Let's look to background study. Deep learning is a branch of machine learning that involves neural networks containing three or more layers. A night driving deep learning model designed to identify distracted driving behaviors. Distracted driving stands as a primary factor contributing to the prevalence of road accident in the present time. So this is deep learning classification. The rise in number of automobiles in Malaysia attribute to heavy traffic on highway. Around 1.35 million people worldwide lost their life in traffic accidents every year, and at least 20 million more suffer injuries. So the total number of road accidents in Malaysia over past decade has increased by 41%. We have six distracted driving behavior. Number one is normal driving. Next, yawning, nodding off, texting, calling, and talking to passenger. So figure five is distracting driving behavior in night driving. Perception V3 is a powerful deep learning model with 159 layers designed for image recognition tasks, including detecting distracted driving behavior. Its multi-branch architecture capture feature at the different scale, making it suitable for complex visual tasks. IR and VIS camera analyze how well the suggest model perform in spotting distracting driver behavior at night rather than during the day. NVIDIA Jetson Nano is an AI-focused embedded module by NVIDIA featuring a powerful GPU and quad-core ARM CPU for accelerate AI workload, GPIO for integration, and low power usage. Ideal for edge computing and IoT application. Next, let's jump to problem statement. So problem statement one is rate of accident increase, automated detection of behaviors faces difficult challenges in night driving. Difficult to achieve better performance to detect image due to low illumination and low light level. Second problem statement is lack of nighttime driving behavior comparison between VIS and IR images in previous research. Behavior recognition is better when driving in the daylight. In daylight, the image capture clearly eye closure, body texture, and mouth closure. The challenge of detecting driving behavior during the night. Third problem statement is to implement the solution as a complete hardware prototype will pose an engineering challenge. Investigation need to be done on how well the behavior detection system perform in actual environment. Deep learning model implementation on hardware is challenging due to the limitation in computational power of embedded system. Next, we go to research objective. The first objective is to implement a CNN deep learning model to detect distracted driving behaviors in night driving. Second objective is to evaluate the performance of the proposed model in the detection of distracted driving behavior in night driving compared to daylight driving using IR and VIS images. The third objective is to validate the prototype of the proposed model based on implementation on the NVIDIA Jetson Nano. So we have four research questions. The first one is how to design a CNN that can detect driving behavior at night. Next, what is the difference in terms of performance between IR and VIS images in the detection of driving behaviors? The third one is how to improve the detection performance using IR images. And last, how to validate the performance of the detector on the NVIDIA Jetson Nano. Let's look to scope and limitation. For the first, high performance CNN models for accurate and fast processing. Next, showcase the benefit of Inception V3 with a balance of accuracy and real-world speed. Number three is emphasize the challenge of low brightness in night vision. Number four is present data collection with 44 participants. Number five, we focus on six distracted driving behaviors, which is normal driving, yawning, nodding off, texting, calling, and talking to passenger. Lastly, data collected using only middle DVR camera and IR camera. So for literature review, we have methods for detecting distracted driving behavior. In this case, we have two. First is conventional and vision-based. For conventional, we have EEG and ECG. And for the vision-based, we have hybrid CNN framework, efficient DET3, Darnet, YOLO, and Inception V3. In literature review, we have computer vision under poor light. And for the first is using the absorption light scattering model ALSM. Next is using generative adversarial network gun based DL on base DL method, deep learning method. So next, related work, we have mobile net and Google Net, ResNet, VGG 16 and 19, and also AlexNet. So as we can see, figure 7 is flowchart of research framework. We have literature review, data collection and data analysis for stage 1, modeling the CNI model for distracted driving behavior detection, stage 2, system development, and for stage 3, prototype integration, hardware implementation on Jetson Nano, lastly, thesis writing. For the figure 8, we have summary of research framework. We have problem statement, objective, methodology, and outcome. For research methodology, figure 9, we have a flowchart of data collection. So first is set up hardware platform. Next, create to session video. Reserve slot for participant. Sanitize, sign, consent form and briefing. Recording video for day and night. That next is data process. So next, we have 20 minutes and 45 seconds for the video duration. Last is extract video into image. So this is hardware and software setup. Figure 10 hardware platform. OBS. Figure 11 OBS Studio software. This one IR camera, DVR camera, and webcam camera. So this is data collection procedure. We have normal driving. Left hand must located at 11 o'clock of the steering wheel, while right hand at the 2 o'clock of the steering wheel. So next behavior is yawning, covering with the left hand and right hand, and also not covering mouth. And for the nodding off, the participant need to do four position, which is front, back, right, and left. So for next behavior is using phone for texting. The phone must be on the same level with the steering wheel. Next, phone must be near to the chest of the participant like this. Yeah. So second last is using phone for calling. So for left hand is for the left ear, right hand for the right ear. Lastly, talking to passenger. The passenger need to look at the left paper that has emoji while driving, and for uh, the right side, participant need to look at the right paper that has emoji while driving. So this is data processing. Uh, for the first, we have 44 participant data. Next, edit video. And after edit video is labeling distracted driving behavior process. And after that, we extract image from the video, which is have 3 frame per second. And next process, filter out the images of the driving behavior. And next, divide image for training, validation, and testing. And lastly, augment the training image for the for driving behavior to stabilize the data. So the next camera placement. we have 7 camera. Left, we have DVR and webcam. Mid, middle, we have DVR and webcam and also IR camera. And at the right, we have DVR camera and webcam camera. For modeling process, we use Python, server, and exception v3. So we can see the uh, confusion matrix figure. We have TP true positive, false negative, false positive, and true negative. So next we look at image classification with exception v3. Figure 18 formula of accuracy, and figure 19 is architecture of exception v3. For hardware development, we use NVIDIA Jetson Nano. This, Jetson Nano is a fast GPU acceleration, enable real-time detection of distracted driving behaviors. It is a low power consumption, compact form factor make it suitable for in-vehicle integration. And last, GPIO and IO interface facilitate seamless sensor integration, enhance model accuracy. So figure 20 is a block diagram of Jetson Nano. So this is hardware development. Figure 21 shows workflow for the model deployment on Jetson Nano. So first thing important that in this the Jetson Nano must detect face detection first. Then we use exception v3 for distracted driving behavior classification. After that, we deploy the driving behavior data to Jetson Nano with the model. So figure 22 shows that Jetson Nano. So you can see the progress, current progress. We have data analysis, the comparison of the night driving performance against day driving. So we have we use exception v3 for day driving, night driving VIS, and night IR. So as we can see, table 1 percentage for driving images using exception v3, and the day driving VIS accuracy 83.6, night VIS 51.47, and last night IR 89.27. So next planning is next current progress is data analysis. We compare the performance between night VIS, night VIS Klahi, and last night IR. For night VIS night VIS, the accuracy is 85.47%. And next, night VIS Klahi, we have accuracy 86.3. For the night IR, 89.27. For next plan, I need to run the experiment for MobileNet V2, GoogleNet, and ResNet 50. So for the next progress, as we can see, the result for day driving VIS using exception v3. So figure 29 is testing confusion metric for the VIS. Next, we have training and validation model accuracy for the VIS. And next, training and validation model loss for the VIS. And last, we have test accuracy for the VIS, which is the test accuracy is 83.6 uh, percent. So next, result for night driving VIS shows the testing coefficient metric for night VIS. And next, we have model accuracy for night VIS and also model loss for night VIS. And last, test accuracy for night VIS. The test accuracy percentage is 85.47. Next is result for night driving VIS with Klahi using exception V3. So as we can see, testing confession metric for night VIS Klahi, and also we have model accuracy for night VIS Klahi, and figure 38. As you can see, model loss for night VIS Klahi, and last test accuracy percentage for night VIS Klahi is uh, 86% point 3 86.3%. So for the last is result for night driving IR using inception V3. So as you can see, the testing confusion metric for night IR. And next, training and validation for model accuracy for night IR, and we have also model loss for night IR, and the test accuracy percentage is 89.27% for night IR. Next is current progress for hardware integration and hardware demonstration. So we can see the video demonstration using desktop. So this one is normal driving. Next is yawning, and after yawning is nodding off behavior. And next, talking to passenger. After talking to passenger, we have calling, and after calling, you can see if there is no driver, the camera will detect no driver. So next, demonstration using driving simulator and Jetson Nano. As we can see, this one is yawning and nodding, and next behavior is talking, and next behavior is calling. The red color is indicate the distracted driving behavior. So next is demonstration in vehicle using Jetson Nano. This experiment we do in UITM. So this one is for the left picture, the result and the terminal. For the middle is Jetson Nano. For the right picture is camera placement in vehicle. So here the result for three distracted driving behavior. We have day VIS, night VIS, naik VIS Kelahi, naik IR. So for the first one is normal drive, second yawning, third nodding off. Table 4 shows the next behavior. Number 4 texting, number 5 calling, number 6 is talking to passenger. So here is my Gantt chart. So after uh, we do the implementation on Jetson Nano, now I'm focused to thesis writing. So this is the status of publication. Uh, in August 2023, the paper objective is day driving and night driving behavior detection using deep learning models. So next, name of conference, ICOICT, and the status is accepted. The progress for status thesis writing is 70%. And lastly is the reference. We have 18 reference. So that's all for me. Thank you.